Hello, Math 20-1. So, in the first chapter of quadratic equations, you guys were reminded of the factoring skills that you learned in Math 10, and we also enriched them with some of the ugly kinds of factoring that we can actually see, like fractions and binomials. And hopefully we're clear on those skills now. And now we're going to actually put them to use with quadratic equations. So the first question is, what is a quadratic equation? Well, let's remind ourselves about equations, period. So first off, let's get started by just simply solving. So I want you to pause and solve this as you would back in grade 9 or something like that. And then come back and see whether I know what I'm doing. Okay, so the first thing, you've come back now. First thing we would do is we would transpose. So I can see in a linear equation, right, not a quadratic, but in a linear equation, we will take our x's to one side. So if I bring the 3x over here, I get 4x minus 3x and equals, I'll take my numbers to the other side. I'll take the minus 10 over to here to be with the 4. So now I'll have the 4 that stayed plus the 10. And now I get a nice little answer like x is equal to 14. And all was good in the land. When we get, we can check that equation and see if that works. But that's how we used to do it. We were able to take variables to one side and numbers to the other and solve it. So when we look at a quadratic equation, that's not going to be the case. So in this next slide, we start looking at, well, what is this quadratic thing that we talk about? So please get your highlighter out and look. This is something above what you would have seen in grade 9. This equation contains a quadratic or second degree term. What is that about? Quadratic is where there's a square. That's degree 2. This one is degree 2. This one is degree 1 right there. And so when you see that term with the variable that's squared and no term higher degree, that's called a quadratic equation. So a quadratic equation is degree 2. And we talked about classifying polynomials in Math 10. That's a degree 2 polynomial. In general, this is the most general possible quadratic equation we could have, where ax squared plus bx plus c represents a quadratic. Remember, it's got a degree 2. There's nothing higher than that, but it must have that degree 2, where a, b, and c are just some constants, right? They're just numbers, right? So there could be anything. It could be 3x squared plus 5x plus 1 equal to 0. It's an equation, but it's got a quadratic term in it. It might be minus 5x squared plus 2x minus 17 equals 0, but it is a quadratic term. So let's think further. If that really made sense, then tell me why these equations are not quadratic. Pause and come back. Why are they not quadratic? Well, you're back. I'm assuming that you understand the definition, and this is not quadratic. This equation is actually a cubic equation. Why? Because it is degree 3. And every type of equation has different skills that you need to factor it. We won't be able to factor that, we won't be able to solve that equation in Math 20. That's going to be a Math 30 problem. This was grade 9, grade 10, because that is degree 1, and that one is linear. Okay? And if you noticed, there's something special that's going to happen. A linear equation, degree 1, only has one solution. We're going to look at what quadratics do, and then maybe we'll come back to this think further question. But in your previous math classes, you only dealt with those ones, and you only had one solution. Now we're in Math 20. How will quadratics change? Okay, well, the skills for a linear, right? The skills for a linear equation, it can't be solved by isolating the variable like we did back here. We're not going to be able to do that. Isolating the variable on one side isn't going to happen. One strategy that you use is by factoring, hence why we reviewed in 3.1. This strategy depends on the following property. the product of two numbers is 0. If the product of two numbers is 0, then either one number is 0 or both numbers are equal 0. In other words, if A times B is equal to 0, then either A equals 0 or B equals 0 or both of them equal 0. But that's the only way that a product can be 0. It's called the zero product property. And if you look at it in terms of kind of a general rule, I'll get this out of the way, then if x plus b times x plus d equals 0, how could that be? Well, that can only happen if this thing is 0. So if you look at this as though somebody's holding this in their hand, Mr. K's picture, and somebody's holding the other one in their other hand, how could you get each of those hands to be 0? For x plus b to be 0, therefore x would equal minus b, because minus b plus b would 0, or x could be equal to minus d. Okay. Hopefully that makes sense, but if it doesn't, you're going to ask tomorrow. But that's the property that we need to use to solve. So maybe it'll become clearer as we go through the next slide. Okay, but that's a zero product property. So next one, we're supposed to solve these quadratic equations. So once again, fill in the blanks that you don't have there. To solve quadratic equations by factoring, apply the zero product property, which states that if the product of two real numbers is 0, then one or both must be 0. Okay, same as what we talked about in the last one. Well, how much does that make sense? Well, go back to our math 10. I got a simple trinomial. I factor that. Right, now remember, this is not an expression, it's an equation. So when you factor it, you get x minus 8 times x minus 2 equals 0. How could that be? How could x minus 8 times x minus 2 be 0? All right, well, the only way it could be 0 is if x minus 8 was equal to 0, then x would have to be equal to 8. And if x minus 2 were be equal to 0, then x would equal 2. Notice that there are two answers for this. There are two solutions. I have a quadratic equation, I have degree 2, and I have two solutions. That didn't used to happen in math 10 or math 9, right? Now I have a tough trinomial. Factor this and tell me what the answers are, right? Review of 3.1. Okay. So now you factored it, you come back. I'm assuming you can factor because you did it. We could use guess and check, whatever method you want, decomposition, but the factors for this are 3x minus 2 times x plus 7, and it equals 0. How can that happen? Only if 3x minus 2 was 0 or if x plus 7 was 0. One of these two, right, from the zero product property, right, one of these two has to be 0. That means that x equals 2/3 or x equals minus 7. Those are the two possible answers. And once again, I've got two solutions. So that's one of the learner outcomes that you should start to see. If you go back to our very first slide, I'll come back. If you go back to our first slide, oops, this one, I had a linear equation, I had one answer. I have a quadratic, and I've been getting 2. And that's really the rule that we can have here. Quadratic equation, because it's degree 2, right up here, degree 2, let's just put a little, that means that there should be two possible solutions. Two possible solutions. If you look at the cubic, whoa, which we'll do in math 30, that's math 30, but that should have 3 possible solutions. Why? Because it's degree 3. So the more the degree, the more the possible solutions are, and there's all kinds of crazy kinds, right? But you start to see why factoring is important. Okay. What about the last one? I probably need to erase that so we're not in the way. So x squared plus 8x. Oh, this is a toughie one. And remember your factoring skills. What was the first method of factoring that you were supposed to always do? I take out a common factor, and I'm left with x times x plus 8. And in the end, that leaves me with an answer of x equals 0 or x equals minus 8. Okay, so you're starting to see that zero product property in play, right? And please again ask, just like always, if that's not making sense, you're going to ask me tomorrow. So now we've got a couple more to do. But they're not set up the same. So, right, we got to build our skills. So when it's set up like this, remember, okay, what kind of an equation is this? It's not a linear. I need to, if you look back at your notes, I need to get it all to one side and be able to use the zero product property. So you need to rewrite any quadratic. You need to take it all to one side. So 3x squared minus 18x minus 81 equals 0. You have to get the 0 by itself, right? You have to get 0 on one side. You can't just expect to factor it in that form, okay? Now I can use the zero product property. I can factor it. So I go through my skills. I factor to 3, and I've got x squared minus 6x minus 27 equals 0. Zero product property. I continue factoring. That is a simple trinomial. So that gives me x minus 9 and x plus 3. And therefore, well, that's just a constant. But for x minus 9, oopsie, for x minus 9, come on. Uh-oh. For x minus 9 to equal 0, that would mean that x would have to be 9. And for x plus 3 to equal 0, that would mean x equals minus 3. So those are my two answers for that question. Okay? Two solutions. In the next example, a little bit more work. Again, you're still going to use the zero product property, but it's quadratic. You have to get equals 0, right? You have to make that happen. So in this question, you got a little bit of work to do, right? First thing we do is 3x squared plus 6. Nothing I can do there, but I need to expand out. X gives me x squared plus 13x, right? I need to take it all to one side. So when I do, I get 3x squared minus x squared plus 6 minus 13x equals 0. Now I have it all on one side. That gives me 2x squared minus 13x plus 6 equals 0. Excuse me. So now Mr. K goes, and again, it's a tough trinomial. This is not 1. So A is not equal to 1. You need to either use guess and check or decomposition, right? So I'm pretty good at this guess and check method. So I'm going to say to myself, I don't feel like doing decomposition, so I'm going to do 2x times 2x. It's a prime number. Now I just need to play, and I think that's going to be a minus 6 and a minus 1, because that'll give me the positive 6 I need, but it'll also give me the minus 13x's. So I factored it. If you don't like that method, then do decomposition, okay? All right, now that we've got the factors, that makes us happy, because therefore, for 2x minus 1 to be 0, I take the 1 to this side, and I get 2x equals 1, and then x equals 1/2. For x minus 6 to equal 0, that means x must be equal to 6. And there are my two answers for this quadratic equation. All right? Hopefully it's starting to come together, right? Whoops. In the next slide, oh boy, not everything is always as pretty as the last example. Sometimes we have some trickier types of questions, right? So our journey in dash 1 is there are going to be many things that come out to or turn out to be quadratic equations. And the first example is you have a radical, and this, again, new journey. So you have this radical. You need to blow this radical up. So we'll take this 4 over to that other side. You can't solve something that has a radical. So we take it to the other side and we get x minus 4. Okay? You might wonder why I did that. Because I need to blow the radical up. And in order to blow this radical up, I need to have the radical by itself. So when I do that, I square it. I square both sides. Now be careful, right? Squaring a radical just blows it up. Just like in Math 10, you end up with 6 minus x. A binomial squared, we talked about this in Math 10. A binomial squared if you want to do it the long way, is x minus 4 times x minus 4. I don't want to do it that way. I remember that the quick method was square the first one, square the last one is positive 16, and multiply the two together and double it is minus 8x. Now I have blown up the radical, and now I see we're back to the same nice quadratic equation that we worked on in the previous set of questions. So I'll take it all to one side and use the zero property. I want to give them two i's. So x squared minus 8x plus 16 is joined from the other side by a minus 6 and a plus x. And in doing that, we now get 0 equals x squared. How many x's? Minus 7x. Minus 7x and plus 10. So 0 equals, that's a simple trinomial, x minus 5 times x minus 2, and therefore x equals 5 or x equals 2. Notice I skipped a step there. I didn't write that x minus 5 equals 0 because I can see that if I put 5 there, it gives me 0, okay? New kind of question. What are we going to do with this? Ponder that. What don't you like about this? Clearly you don't like 2 and 4. So because you have an equation is a balance. And you can do anything you want to the equation for the most part, as long as you do it to the same sides. So because I don't like 4 and 2, I know that my lowest common denominator is equal to 4, so I choose to multiply the whole equation by 4. Multiply by 4, multiply by 4, multiply by 4. That will make me happy. Do you know why? Because now 2 divides into 4 and gives me 2. 4 divides into 4 and gives me 1. And there isn't anything to divide here, so that's just going to be 12. And that makes me happy because I no longer have fractions. What I do have is a nice new equation without fraction that is 2x squared minus 5x is equal to 12. I bring it all to one side, and 2x squared minus 5x minus 12 equals 0. Okay. Now, even though I would prefer to do guess and check, Mr. K is going to be a good guy, and I'll pretend I don't know it, and I'm going to do decomposition. So I have a sum equal to negative 5 and a product equal to minus 24. That gives me numbers of minus 8 and positive 3. That tells me that 2x squared minus 8x plus 3x minus 12 equals 0. So I take out a 2x and I get x minus 4. I take out a plus 3 and I get x minus 4. That gives me factors of x minus 4 times 2x plus 3. And I now know that for x minus 4 to equal 0, x equals 4. That's my answer. And for 2x plus 3 to equal 0, I know that x would have to be equal to minus 3 over 2. And those are my two answers for this bigger or trickier quadratic equation. Whoa. Really? That's cool. Okay, your assignment is on your sheet. Off you go. Last little question, a bit of enrichment, is not so much a question, but I just wanted to show you. Sometimes you are asked to come up with an equation giving you know the answers. So in this question, somebody says, by the way, did you know that my question has answers of minus 6 and 3? Do you know what my question was? You should be able to go back to the factors if you know it. So it's using the zero product property backwards. If x equals minus 6 is the answer, that must have been x plus 6 was the factor. And if x equals 3 was the answer, then x minus 3 was the question, was the factor, right? So if you put those two together, you get a quadratic equation there. So you can come up with the equation based on the answers. What if x was minus 3 halves and 4 thirds? That's a little trickier. But if x equals minus 3 halves was the answer, then the question, right? The question, if you cross multiply, 2x must be equal to minus 3. That must mean that the factor was 2x minus 3, and the other one must have been 3x minus 4. Okay, going backwards from the answers to the question. So the quadratic equation would be 2x plus 3 times 3x minus 4, which would give you 6x squared plus x minus 12. Nice. Okay, see you guys tomorrow. Well done.